G'day, it's Clinton Brett here from Diesel Help Australia. Thanks for purchasing our DPF and Turbo Boost kit. In a box like this, you'll be familiar with it by now, I'm sure. But if you're not familiar with it, I like to run through a few little extra tips to help you understand what you're testing and why, and how you can utilize these tools to carry out a correct diagnosis of a DPF or a turbo itself. One of the issues we see with turbo sensors and DPF differential pressure sensors are exposed to the extreme elements. We're talking about a lot of excess carbon, excessive heat, excessive cold temperatures. Condensation's a big problem as well. So what you're reading on the scan tool may not be exactly what the vehicle's actually seen at the sensor. So by implementing a gauge like this will enable you to confirm the actual pressure at the position where the sensor is located. If that's working fine, then you need to be able to go back and look at where the possible other problems are that may be interfering with the sensor. So some of the boost sensors are located on the vehicle, on the engine itself. Some of the sensors are located away from the engine, attached to the firewall. So particularly the DPF differential pressure sensor, that is something that's located away from the engine on most vehicles, apart from some of the few such as the Subaru diesel range. They're adapted to the front of the engine itself. So in situations when you get symptoms such as a turbo boost code, EGR related code, you may get a DPF code, you may get an airflow code. In any situation, you'll find this tool very useful. This is an electronic system. It's reading electronic signals from the differential pressure sensor for the DPF and also the map sensor, the turbo sensor itself. They're an electronic item. Now inside here, there's temperature sensors and there's also a measurement of the atmosphere pressure, and that overall is also including the boost pressure itself inside the intake manifold. Because we rely on the scan tool to look for that data, and that data might come back inaccurate. And what we're looking at on the scan tool, we believe is the real data. So to confirm that sensor is actually working, it's best to adapt an analog gauge. That way you'll be able to see the real actual changing of the boost pressure or your differential pressure sensor. To carry out the actual boost test, you need to be able to run it under load. Yes, you can sit there free rev it in the driveway, but that's not going to give you an accurate reading of the boost gauge itself. You need to be driving under load in driving situation. Same with the DPF tester. When running the boost gauge, I don't know the exact boost of every vehicle. So that's something you're going to have to look and refer to the manufacturer's specification, or even look at a good vehicle to see what the boost sensor is. The thing is though, it's not so much about looking at how much boost it actually gets. Yes, that's a great advantage to understand how much boost it gets. The scan tool will tell you that. What we're using this gauge for today is to compare the scan tool data from the actual pressure you're reading with an analog gauge. The other thing is you're going to look at when you're testing your differential pressure sensor for your DPF. At idle, you want to see less than half a kPa. Under cruising, no load, say around about 60 k's an hour, you could be looking at around about no more than 6 kPa. When you're running it under load, full boost, full throttle, usually above 80 k's an hour, if it's pushing higher than 20 kPa, then I suspect you've got a problem. But if your analog gauge reads below that specification, that's a great confirmation for you to know that there's not a problem with the DPF. Where you're actually measuring that is on the pressure side of the DPF filter itself. So you need to locate the differential pressure sensor first to see where you're going to tee in. You need to follow the hose down, follow to the DPF and determine that is the pressure side. The pressure side is the engine side. On some DPF differential pressure sensors, there is a paint mark. It could be yellow, red, depending on the manufacturer. That is also an indicator of the pressure side of the DPF. I've actually adapted one of our quick release fittings which tees into the main hose for the main pressure of the DPF, and then it tees off and runs back into the sensor itself. So you want to keep the sensor remained plugged in electronically, and what we're doing is we're actually using an analog gauge, mechanical analog gauge, to do a comparison of the differential pressure sensor or differential pressure itself. So we need to make sure that it matches. This can assist you to diagnose DPF faults. Quite commonly, differential pressure sensors do fail because of their elements they're exposed to. Okay, so I'm going to show you what's included in the DPF and Turbo Boost test kit. It comes with a DPF test gauge, and it comes with a test gauge for checking your turbo boost or map sensor, as it's often referred to. The DPF test gauge is rated from 0 to 60 kPa, that's 0 to 8.7 psi. The turbo test gauge is rated from 0 to 400 kPa or 0 to 58 psi. They're both liquid filled to ensure a dampening effect rather than getting the gauge bouncing around. Everything in the kit is designed, manufactured and sourced within Australia. The kit also includes an adapter. This is for your map/boost sensor adapter. This enables you to adapt into the intake manifold and then piggyback your map sensor on the back of it whilst remaining in the wire and harness, and that is to confirm that the map sensor is reading accurately when looking at the scan tool in comparison to the gauge itself. The DPF test part of it includes an 8mm barbed, which enables you to tee into between the pressure side of the DPF and the differential pressure sensor of the DPF, which is often located away from the DPF on the firewall or in the vicinity of the engine bay. Okay, both adapters come with a barbed fitting. The DPF has an 8mm barb fitting, and the turbo boost kit has a 3mm barb fitting. The kit doesn't include hoses. We find that that is something you can purchase yourself easily and readily available for one of your own suppliers. You may find you may have to make a longer length. You can fit a 2 to 3mm ID rubber or silicone boost or vacuum hose. Now I find that running a length of around about 3 meters is more than adequate to run this from the manifold on a 4-cylinder through the grille and up along the side of the car and into the window of the car and securing the gauge within the vehicle itself. The actual DPF, we work on an average size of 8mm ID for the hose, thus we use the T-piece here. That's to run the rub, to tee it into your differential pressure sensor pressure side of the DPF. And again, probably looking around about a 3 meter length of rubber hose for that one. That rubber hose, you want to be careful. You want to look at something that's more heat proof, exposed to the extreme heat of the exhaust system itself. So the best thing with a gauge is to try to secure it so it doesn't flop around too much and doesn't rattle too much. You've got to ensure that you can see the gauge, but also ensure that you can see the road. Make sure you're aware of your surroundings. Don't let this block your vision. If you can, take a passenger with you to carry out the test. In some of the 4-wheel drives, I use the grab handle. I wrap a bit of tape around the gauge and wrap around, as shown on the video here. Okay, so it's quite easy to adapt the boost map sensor adapter. All we do is you need to locate your map sensor on your intake manifold. The sample we're using today is off the 2013 model V6 Jeep Cherokee. The other vehicle we're demonstrating today is a 21 model SsangYong Musso 4-cylinder 2.2 litre using a cast alloy manifold with a map sensor bolted into the manifold itself. I highly recommend, if possible, leave the actual harness plugged into the map sensor. One of the problems we face with age on vehicles is that the plastic becomes very hard and brittle and exposed to heat and a lot of dirt and everything around it, and it can be quite difficult to unplug some of the map sensor harnesses. So rather than risking breaking the harness plug and then cause another issue, is try to leave it plugged into the map sensor, and it might be worth just unbolting a few clamps on the harness itself to give you a bit of freedom in movement on the harness. Okay, so once you've moved it out, if there's any carbon in the base of this, I strongly recommend to just give it a bit of a tap on the bench itself. So all you're going to do is just give it a bit of a tap. Okay, if any carbon comes out of there, that'll be less chance of the carbon being caught up in the gauge itself when you're actually doing the test. So what we're going to do now is we're going to grab our boost sensor adapter, check that the O-ring is in a good condition. It's okay to put a little bit of grease on there, but what we're using a Viton type rubber seal. and it's quite an easy fit in there, and it's a nice snug fit. And what we do as well is we know that this is okay, it's all clear here. Now if you had this on the other side here and there was a hampering such as this plastic here, then you can change this, you can move this screw to there. There's two options to move the outlet for the pressure gauge. Okay, and then just check the O-ring is okay on the map sensor itself. So using the longer bolt included in the kit enables you to attach the sensor to your adapter and ensure a good seal. I recommend you tighten up to the manufacturer's specification for the bolt for the actual map sensor itself. And all you do now is just run. If it's hard to get to the hose outlet, it's also just as easy to attach the hose before you actually mount the adapter on the intake manifold. Elongated slot allows you to maneuver it around in different positions. Then you're going to run this hose all the way up through the grill and up along the side of the panel itself and run it into the window of the vehicle.